Hello everyone. Good morning, good afternoon, good evening, depending on where you are joining us from. So welcome back to yet another webinar on Kubernetes. This time I'm excited to bring config maps and secrets and how you can use that. So those of you who are joining us for the first time, my name is Janaki Ram. I'm a Google developer expert based out of Hyderabad, India. I am the Cloud Native Computing Foundation's ambassador from Hyderabad. I would love to evangelize Kubernetes and spread the word among developers and IT pros. So we have been running this series for a while. This is 7th or 8th webinar in this series that we have been delivering. So let's get started. So config maps are a very useful mechanism for injecting configuration into Kubernetes applications. So I'm going to touch upon the concepts of config maps. What exactly are config maps? When are they used? What are the top use cases? Followed by another very important concept in Kubernetes called the secrets. So secrets are very similar to config maps, except that they bring in sensitive information into pods and containers. And finally, there are some gotchas that you need to be aware of. So we'll cover them in the key takeaways with do's and don'ts. So I hope you're able to listen to my audio and follow what is going on in the screen. If there are issues, do use the questions tab to let us know if you have problems with any of the audio or video related issues. So let me get started. If you are familiar with developing and deploying applications, you know the challenges involved in dealing with configuration. Starting from Windows applications back in 90s to the latest distributed computing, distributed applications that we are developing, configuration is an integral part of applications. Typically, the configuration is fed to the applications through configuration files, which are available in the form of INI files or XML files or JSON files, and sometimes even a custom format. But irrespective of how the configuration is fed, they contain external metadata that the application would use to talk to various resources or to reconfigure itself. Sometimes the configuration is passed along through command line arguments, and sometimes through environment variables. So irrespective of how it is passed along, configuration is a critical aspect of any kind of application that we deal with. It could be a simple desktop app to a web application or to the contemporary microservices. Configuration holds the key to decoupling the actual application execution from the runtime data that it needs to perform better. For example, in the good old days, the ODBC configuration was passed to the application through registry in Windows. And when Java became popular, the XML file, the deployment descriptor, which consisted of various parameters that control the jar files and var files, came into picture. And more recently, JSON files started holding that kind of configuration. Now with distributed applications, we are typically storing that kind of configuration in a distributed key value store like Console or HD. But the key thing to understand is configuration should be always kept separate from applications. It's more important for container applications because the images got to be extremely portable, and to keep them portable and to keep them more agile, we need to split the configuration from the images. It's not a good idea to hardwire configuration into images. And this configuration should only be passed at runtime when the container is actually in the execution mode. Just like there have been a lot of cases where AWS secret keys and access keys were found in GitHub, and that was used for mining Bitcoins. There are many instances where Docker images were found with very sensitive usernames, passwords, connection strings embedded inside them. So that is the biggest risk you would face when you are bundling the configuration with your application as a form of image. So config maps are a mechanism to separate the concern of configuration from the core application. It is one of the Kubernetes objects for injecting containers with configuration data at runtime. And one of the core design principles of config maps is to ensure that the applications that are deployed in Kubernetes are actually agnostic to Kubernetes, which means just because you are deploying an application in Kubernetes, it doesn't mean you have to modify the application or refactor the application. For example, one of the ideas could be to leverage the XD distributed key value store that Kubernetes relies on. It's not a bad idea to use the same for storing some configuration required by your applications. But that actually means refactoring your application to make sure that it understands how to talk to XD. So you have to modify that section of your application that is reading from configuration in a standard form to using a more contemporary evolving mechanism of something like XD. And that also locks your application into Kubernetes, making it hard for you to move it to any other container orchestration or any other runtime environment. So config maps are primarily designed to ensure that applications continue to behave like they are running as standalone applications without the knowledge of running within Kubernetes, but yet taking advantage of the new paradigm where they are highly scalable and they are highly portable. So config maps can be used to store fine-grained or coarse-grained configuration. For example, you can pass individual properties, which are just like key value pairs, or you could also take a complete configuration file, templatize that, and pass that to your application. Typical examples include my.cnf, which is a MySQL configuration file, or a php.ini, which contains a lot of configuration settings for PHP, and Apache configuration files or Nginx configuration files. So they are completely self-contained in carrying a lot of switches and settings that will influence the runtime behavior of applications. So that entire configuration can be manipulated through config maps and fed to the containers and pods that are running the actual applications. It can also be JSON files, as I mentioned earlier, but it doesn't matter how you're actually feeding, but config maps are basically holding key value pairs that are accessed by the pods at runtime. These are typically exposed to the containers and pods through a dedicated volume, and that basically emulates something like a /etc directory, which contains a variety of configuration files in Linux. So we'll see a demo where we'll actually deploy a pod and then use a config map to configure that, but it emulates something very similar to /etc directory and configuration files that are within the /etc directory in Linux. As I mentioned earlier, config maps are first-class citizens in Kubernetes world, which means they are just like any other API object, like a pod or a replication controller or a replica set or a service. You basically define a config map as an API object, and it contains data section where you feed multiple key value pairs. It could be individual keys followed by values, or you could also create a file that holds a set of properties or a set of keys with multiple values. It's also possible to create a config map from an existing file that already contains configuration. We'll actually see a demo of that. So once you create a config map, which is independent of the pod or the container that you're going to read from, you can map it to the pod and the containers that are going to read from this config map. So the screenshot that you see here has two different objects. The first object is the config map, which creates two keys, the how and type. And when we are actually launching the container, which is a busybox container, we are defining the config map key ref. And this section is the pointer to the config map, which the pod will use at runtime. So config maps can be used to populate three different sections. The first one is environment variables. So the environment variables are the most common mechanism, and in fact, this makes your application extremely portable. You can never, you're never bound to a specific environment or a specific orchestration engine if you are using environment variables. Your application can always read from a set of expected environment variables irrespective of where it is actually launched and where it is running. That means you can safely assume that the container will run exactly the same way across multiple environments. You could also pass along the configuration settings as a command line argument, and config map supports that as well. And finally, you can pre-populate configuration files that are exposed as the file system to the container and pod. So if your application is expected to read from a specific configuration file from the file system, let's say your application expects the file to be available in /etc or /opt followed by another path and a specific file, you can emulate that through the config map. So the idea is to create the configuration, a low-touch mechanism where applications that are already capable of reading from any of these well-known locations will continue to run independent of where they're actually deployed. So all the popular choices, including environment variables, command line arguments, and file system locations, are supported by config maps in Kubernetes. User and system components store configuration in config map, which means Kubernetes itself leverages config map for a variety of settings. So it's time for us to take a look at what are config maps and how to use them. So I have two different scenarios that will highlight how to use config maps in your application. So let me jump to the demo. And here I have a folder called config map. And I have the first demo. Let me walk you through a set of steps. So the very first thing that we are going to do is to create a config map YAML file. So the scenario is this. I have a web application and I want to define the parameters related to the level of logging and the location where it's going to log. This is a very real world scenario. Particularly in microservices environment, you would always want to define how your logging is going to work. For example, I can change this to info to log all the information to a specific location. Local will write it to /logs, or I could change this to something like New Relic or any other elk stack endpoint. So it doesn't really matter what it is, but the idea is to decouple the logging information, logging configuration from your application. So the entire application, which is composed of a set of containers, will read from this configuration and will define the logging mechanism accordingly. So this is a real world scenario where you would want to influence logging of your applications at runtime, through a different configuration. So if you notice, this is a very simple Kubernetes object. It starts with API version v1, kind config map, very similar to how you define a pod. And then there is, of course, metadata. So I'm defining this as log config. And you can also define namespace. Basically, a config map is available across the namespace. And then this is the data section where you can create a set of key value pairs. So the first key that I'm creating is log.level, and I'm defining that as info, and location is local. So this is the config map that I'm creating. Let's see how we are going to consume this from a pod, right? So the very first scenario is, let's say, from command line, right? So when I am launching my application, I want to pass these two parameters from the command line. So this is a pod, a standard definition. But here, if you carefully notice, I'm actually defining this with the log level environment variable and error location, which is coming from the log location. So this is going to define where and what level of logging I'm going to perform. So once I define that, I use the standard environment section. And here you notice that I'm defining log level. This is the section which is reflecting here. And I'm saying grab the key value pair from config map keyref, and the name is log config, which basically maps to this. So this is pretty straightforward. We are setting a one-on-one relationship between the pod and the config map. And then I define another variable, another configuration setting, which is log location. And again, this is coming from log config, config map. But the key that I want to grab is log.location. So that's it. Now we are going to basically access this at runtime. So let's go ahead and create the config map. So the very first step is to create the config map, right? And then you can always access this with get config map. So now we created the config map. You can also grab the YAML output from this with -o YAML. And this basically shows the actual declaration of our config map. So now I'm defining the log level as warning and log location is local. Now it's time for us to create the pod, right? So let's go ahead and create the pod. So, oops, I haven't created the pod. So let me first create the pod and give it a minute for creation. So this is going to take, okay, now since nothing is holding the pod in the background, it is just done. So now if I actually use -a, it shows that the pod has been created and it is also done. It is completed. So now if I actually access the logs, you notice that the error level was set to warning and the error location is set to local. And this is exactly how we define that in the pod definition. So it is basically reading from this and it is passed to the command line variables. So if I have an app, of course, I'm running the tiny busy box with a simple shell, but effectively I could have passed this configuration to a Node.js app or to a PHP app or basically anything that would expect these inputs coming from the command line. So it's not very different. All right, so that was the first mechanism where we have passed the configuration through command line. Now let's actually access this from the environment, right? Environment variables. So how do I define? It is not very different. So this time, instead of terminating the process, I'm basically running a loop because I really want to see the environment variables inside the pod. So let's actually execute this. So for that, I'm going to create the next pod, which is going to access the environment variables. So let's make sure this is up and running, and it is. So now I'm going to do an exec into it. Okay, let me, I guess this is the name of this pod is test pod env. So let me use that. Okay, so now we are inside the BusyBox shell, and when I actually do an env, you'll notice that the log location and the log level are exposed as environment variables. Again, this is a standard mechanism. I can use any language of my choice to basically read from the environment variable and decide what level of logging needs to be done at runtime. So this is a phenomenal way of injecting configuration without refactoring, redesigning, or manipulating your app to take advantage of Kubernetes. It can just remain as is, as long as you're reading it from environment variables or command line variables, the app continues to work. So this is a great mechanism for you to decouple configuration from runtime. That's not all. I finally want to show you another robust mechanism where we actually read it from file system. So this time, I want to expose the config map not just as command line variables or environment variables, but read it from the file system. So this is another mechanism for high backward compatibility. If your application is expecting to read from, let's say, a path, something like xconfig, will emulate both the settings that we populated as files in this location. And if you notice how we are creating this volume, this is very different from creating a standard persistent volume with persistent volume claim. So here I'm defining the volume name as config volume, and that's what is being referred in the volume mount section. But here I use config map and point it to log config that we created earlier. So this log config is going to be populated at this directory, and both the settings, both the keys that we created in config map will now become available as files under xconfig. So let's go ahead and create those pods. Okay, so now test pod wall is created. Let's check if it is ready. So now let's go ahead and execute the shell. So now we are inside the BusyBox shell. So now let's go to /etc and config, right? Now if I do an ls, log.level and log.location are basically exposed as files. So let's do a cat, right? So this is the warning, which is the level of logging that I want to do. And similarly, log.location is local. So this is another phenomenal way of making applications read from the configuration without ever touching them. So this is the third use case where you would access configuration from applications at runtime. So to summarize, we basically create a configuration outside of the application, independent of the containers and pods that you're going to create, and then define these pods either to read from the command line or from environment variables or from the file system. Now, few things to remember. If you change the configuration after the creation of pods, it's not going to get reflected in any of these pods. That is the biggest catch that you need to factor, you need to understand. This is not dynamic. It is not a distributed cache or a distributed key value store like HT, where you read multiple times and you write and it immediately propagates. So if you have to update the configuration, you have to, of course, do it at config map level, and then any pod that is launched after the configuration update will effectively take advantage of that. The pods that were launched before the updation of config map will continue to use the old configuration. So this is not highly useful, ideally for applications that are dependent on configuration at runtime. They'll benefit more if the configuration settings and the configuration is dynamically available. Like, I can change my database connection string at runtime and the subsequent request will now start going to a different database. That would be phenomenal, but Kubernetes doesn't support that yet. Maybe that's in the pipeline, And based on my understanding, it is definitely in the pipeline. But as of now, as of Kubernetes 1.5, this is still not available. So you got to make sure that you kill the current pods and you launch them again to make the configuration effective. All right, so let's do a bit of cleanup and move to the next demo. All right. Okay, so that was the first demo of ConfigMaps. I want to show you one more, which is more realistic. So let me show you another demo, which is going to be slightly different. So this is actually a configuration where we are going to manipulate Redis configuration at runtime. So we are going to inject two different settings. One is max memory, the other one is max memory policy. These two are very critical for Redis. So we define that in a file. If you notice, this is how a Redis configuration file would be, but we are only updating two settings. This is just an independent file that contains these two settings. And then let's actually see how we can launch Redis, which will read this configuration at runtime. So the very first step is to create the configuration from file. So earlier we created it directly from a YAML file where we created the config map as an object, and then we defined the key value pair within the YAML file. But here I'm creating this from a file. This is how you would inject the typical configuration files coming from MySQL, Nginx, Apache, or for that matter, MongoDB. Anything that expects a templatized configuration file can take advantage of the from file setting. So let's go ahead and create the example Redis config. So I just created a new config map. So if you do kubectl get config map, you will see that we just created this example Redis config. Then I go ahead and create redis.yaml, which is actually a pod. But let's take a look at the definition of this pod. So this is actually a typical Redis container packaged as a pod. But here, we are using volume mounts to read from the configuration. So Redis master, it is coming from the configuration. So the way we are mapping the configuration to this container is by creating a volume that is pointing to config map, which is based on the example Redis config that we created in the previous step. And it is reading from Redis config. The path is redis.conf, which is the standard location where Redis expects the configuration file to be. And we are exposing that to the config value that we created, which is exposed at Redis master. So this is more realistic. We are now actually affecting a Redis deployment through the config map. So let's go ahead and create the Redis pod. Okay, so now Redis is up and running. Now all I'm going to do is directly launch the Redis CLI. So kubectl exit followed by Redis command line interface. And now this drops us right into the CLI of Redis. So now let's check the max memory. So this max memory setting that we are trying to read is actually what we fed through the config map. So this is the same value that we basically mentioned here, 5 MB. So that is now translated into the elaborate form. So it's basically showing us in bytes, but it is the same config setting that we have passed from the config map. And similarly, the max memory policy is all keys are LRU. So let's also go ahead and check the max memory policy. And that's what we fed through the config map. So this is another example of how you can inject configuration through config map into a container, right? So let's exit. Let's do a bit of cleanup and move to the next section of our session. All right, so that was all about config maps. Now let me take you to secrets. So technically, secrets came in before config maps. In terms of Kubernetes feature pipeline, secrets came in just before config maps were introduced. But there is a lot of similarity between secrets and config maps. And I thought I would first talk to you about config maps and then set the context for secrets, because they are very similar. At a very high level, secrets are like config maps but meant for sensitive data. So if a config map can be pretty much read by any container, any pod in the namespace, with environment variables, secrets are slightly more granular, more specific to the containers and pods that you want to access from. So secret is also a Kubernetes object that contains a small amount of sensitive data, something like a password, a database username, an API key, or even PEM files if you're actually using SSL. So all of them make good candidates for you to package secrets. So secrets reduce the risk of exposing sensitive data to unwanted entities. Again, in most of the scenarios, we are tempted to actually use username, passwords, and sensitive data as a part of configuration files or as a part of our image. And when we actually pull them and push them into the hub, the Docker hub or a private registry, unfortunately, the sensitive data also goes along with it. So the concept of secret will, again, decouple sensitive data from images so that only at runtime you are able to inject the sensitive data very selectively into the pod and the container that needs it. So like config maps, secrets are also created outside of the pod and containers. They have no clue who is going to use them. They are completely independent, and again, they are first-class API objects of Kubernetes. Like config maps, secrets also belong to a specific Kubernetes namespace. And the size of each secret cannot exceed 1 MB. Given the use case and the design goal of secrets, this is not a big deal because I don't think any of your passwords will be more than 1 MB. So a bit of workflow and behind the scenes architecture. So secrets are basically registered with Kubernetes master. So every secret that you create will be centrally managed by Kubernetes master. Again, like config maps, secrets can be mounted as volumes or can be exposed as environment variables. Given the sensitivity, it's not a good idea to pass them as command line variables. So that's the reason why they are either exposed as environment variables or volumes. Secret is only sent to the node hosting the pod that requires access. This is the key thing to understand about secrets. One of the design goals of secret is to avoid the pitfalls of traditional configuration management tools like Chef, Puppet, Ansible, SaltStack, and so on. They also manage secrets. They also manage sensitive information. But the challenge with these tools is they basically broadcast the secret to all the nodes, whether the app is running or not. The secret that you create in a Chef cookbook or a recipe or an Ansible playbook gets broadcasted and gets injected into pretty much every node, irrespective of whether it's actually running the app or not. And that's not a good idea. Whereas secret is specifically sent to the node that is running the pod which demands the secret. That means it's not going to be a broadcast to all the nodes, but the secret is selectively sent to the node where the pod is running, which is demanding the access to secret. So this makes it very, very fine-grained and very selective and more secure, obviously, because it's more choosy in terms of where it is targeting the secret. Each secret is stored in tempfs volumes with restricted access to rest of the applications in the node. This is another important thing. Because it is stored in tempfs, an application running in another pod, another container cannot access. This is very selective to the pod or the container that demands the secret. So you cannot accidentally read a secret that belongs to a specific pod from another ad hoc or a random request. So that is another mechanism of exposing the data, sensitive data secretly or more selectively to the application. The communication between the API server and node, which is actually the Kubernetes master, and the node is secured through SSL and TLS. And now if you're curious where the secret is actually stored, that is again going to be in etcd. So when the pod actually demands the secret, it is securely transmitted from the API server, which is the Kubernetes master, to the node on which the pod is running. So nothing better than looking at a demo and understanding how you create secrets, and we'll come back and then discuss about the takeaways and some of the gotchas that you need to be aware of. So let's move to the next demo with secrets. And I have two demos. One is the simple demo to introduce the concept. The other one is slightly more real world based scenario. Okay, so let me make sure I close all the files that we don't need. Okay, so to start with, I have created two files. One is called username.txt, which contains admin, and there is a password.txt that contains some password, which is supposed to be our secret. And now we are going to follow the same workflow like ConfigMap. So what do? We first go ahead and create a generic secret called dbsecret, and it is coming from these two files. Right? So here, if the very first command is about creating the secret, right? So we are creating something called database secret. So let's get secret. Okay, so this is the DB secret, which is opaque and contains two different entities, right? So that's the very first step. So now that we created a secret from the file that contains the username and password, the next step is to basically create the pod. But before that, let's experiment a little bit. Okay, so let's actually look at the YAML definition that is stored inside Kubernetes. So when I use -o YAML, it basically throws the YAML spec for our pod, sorry, for our secret. And this actually contains the data. So this data has password.txt, and this looks very different from what we used. And this is nothing but a base64 encoded text of our original username and password. What is the proof? If you actually grab this and do an echo and send it to this command base64, oops. Okay, decrypt, yeah. So now this actually shows us the password that we originally put in the file as a secret, right? The same thing, we can retrieve the username as well. So this is the password. If you actually grab the username, which is stored here, and use the base64 utility to decrypt, it shows us admin. So that means Kubernetes does a simple base64 encoding before storing that as a secret. This came as a surprise to me because I always thought Kubernetes uses a better mechanism to store the sensitive data, but it is using very simple base64. So that means you cannot rely on this for MD5 or the sophisticated encryption. The idea is very simple. How do you selectively inject sensitive data to a set of pods and containers? The primary difference between ConfigMaps and Secrets is ConfigMaps is more broadly available with less restrictions. Secrets are like ConfigMaps. They're not encrypted, mind you. They're not based on any sophisticated encryption algorithm. They are simple base64 encoded strings. But the fact that they are selectively injected makes them better than ConfigMaps. But this is not foolproof. That's the key thing to understand. All right, so now we have gone ahead and created the secret, and we have also explored and realized that Kubernetes is storing our secrets as base64 encoded strings. Let's go ahead and create the pod. So before we create the pod, let's take a look at the definition. Again, this is going to be exposed as file system, right? So everything remains the same. We are creating a pod with one container, which is Redis, and here we are creating a volume mount, and we are calling this as etc foo, and this is coming from the volume called foo, which is based on the secret, and this secret is db secret, which we have defined earlier, right? Which we have defined here. Actually, it's not a YAML file. So this is how we created our db secret from the command line from kubectl, and that's what is available here, right? So now we are basically asking Kubernetes to expose db secret as a file system, as a mount point at etc foo, right? So let's go ahead and create this pod and then check out the file system. All right, so let's give it a few seconds for Redis to get pulled. I have already fetched the image, so that's been fast. So now what we're going to do is to log in, or rather SSH, or no, it's not even SSH, it's basically accessing the shell of the running Kubernetes, running Redis pod inside the Kubernetes. So now we are inside the Redis pod, and when I go to etc foo, you see username.txt and password.txt. So now we can check out the values. It is not encrypted or encoded. It is available as plain text. In whatever format you have used, it is now exposed. But this is definitely better than ConfigMaps. As I said, this is more secure. This is slightly more selective in terms of broadcasting the configuration data, and this is available only to the container and pod in which we have declared and in which we have requested. So this is definitely a better mechanism than hardwiring your username and password inside a specific pod, right? So that was the first mechanism of using secrets inside the pod. So let's go ahead and clean up because I don't want to leave them hanging and interfere with our next demo. So I want to show you one more demo which is slightly different. So what we do here is creating the secret from the command line, but we encode the username and password instead of leaving it to Kubernetes, right? So now what I'm going to do is to basically run these two commands, which we have already seen, and we are basically encoding the admin and password, the values of username and password into base64 strings. We'll grab them and then define the secret object. So earlier in the previous demo, we have created it from the kubectl command, but here we are actually defining an object, which is the secret object in full-fledged YAML definition. So here we populate username and password, which are nothing but the base64 encoded strings coming from our command line. So pretty straightforward. And then everything else remains the same. So now I go ahead and create my secret. So if you do get secrets, you'll actually see there is a my secret that's created. Then we'll also create a pod. And by the way, the definition of pod is also slightly different. Okay, this time we are not exposing that as a file system. Now we are actually accessing that from the environment variables. So here, if you look at the notion that we are following, There is env, which is a standard mechanism to inject environment variables. So we are creating an environment variable called secret username. And where is the value coming from? Secret key ref, which is pointing to my secret object that we have created in the previous step. And the key that we want to expose is username. Same thing here, it is the password. So what I'm showing here, there are two different mechanisms when compared to the previous step. Here we are not actually creating straight from the command line, we are creating an object. There are advantages. For example, later on I can come back, I can modify this, and I can do an apply, and this becomes effective. That is the first mechanism. The second mechanism that we are doing differently here is we are not exposing this as a /etc foo directory. Instead, we are injecting as environment variables, right? So let's go ahead and create the pod. Okay. Hopefully this also gets created quickly because I have already pulled the images on every node of my cluster, and there we go. So now the pod is up and running. So let's get into the shell and do an env. And here it is. So secret username is admin. Secret password is some password that we created earlier. Now my app can read the username and password dynamically from the environment variables. So this is how you basically deal with broader configuration through config maps and sensitive data through secrets. Personally, I feel there is a lot of work that needs to be done in this part of Kubernetes implementation, because while config maps are definitely powerful and attack a set of use cases, secrets need a little bit of work. I would personally love to see where I'm allowed to define some kind of an encryption mechanism with a salt of my choice, so that I can create a set of usernames and passwords or sensitive data with my key, and then I only send the key to the pod, which it will use to decrypt. So it makes it more robust. But again, the challenge with that approach is you are essentially making this work only with Kubernetes. I guess the reason why it is kept very open, where the responsibility of encryption and decryption is pretty much left to the developer, is because you're not really interfering with the way an app is designed, developed, and deployed. You're free to use an encryption scheme of your choice without Kubernetes interfering or influencing your design in any way. But again, nothing stops you from doing it with the current secret design, because ultimately it is a base64 encoded. You can, before you feed it to Kubernetes, you could actually encrypt it, grab the key, and then use base64, store that in Kubernetes, and again use your custom, bring your own decryption mechanism at runtime to read the values. That would actually make a lot of sense. But again, Kubernetes doesn't want to enforce what kind of encryption scheme you want to use, because it's outside of the scope of your application design. So that is the reason why secrets are kept more open and more broad, and they do solve a big problem. But ideally, they should give you a little more choice than just using base64. All right, so time for us to get back to the deck and summarize a few things. So secrets feature is not entirely foolproof, as we have seen. Mind you, it is using base64, so you got to be cautious. You can't rely on that. But having said that, it is still better than config maps. It is still better than using traditional config management tools. The other thing that you need to know is API server of Kubernetes stores secrets in plain text. It's a big red flag. That means anyone who has access to the API server will be able to enumerate and read all the secrets. Not a good idea, but that's how the current design is. I'm assuming this is going to change in the future, but as of now, everything is stored in plain text. And again, if you're running more than one XD cluster, there's a typo there, it's actually XD cluster. And when the secrets are replicated across the HD cluster, because ultimately HD is the home for config maps and secrets. So when you have more than one HD node in a cluster, during the replication, it is propagated in plain text. Again, a big red flag, because anyone who has access to HD will be able to retrieve the config maps and secrets. So again, that's a gotcha that you need to be aware of. Secret definitions may still get exposed if someone is very determined to really break this and figure out what is there in the secret. It's not very hard, so it is not completely bulletproof. So that's what I really meant by not totally relying on secrets as your mechanism for storing sensitive data. So those are the things to remember, but again, they do come very handy. And I hope you got a chance to visualize the use cases and scenarios where you can use the config maps and secrets. Well, that brings us to the end of this part of webinar series. And I'm very excited to announce the next webinar on scaling and managing deployments. So deployments in Kubernetes are PaaS-like capabilities. Now you can basically pause, resume, update, scale your deployments. You can patch them. You can perform rolling upgrades. You can drain the nodes. You can drain the pods. You can perform rollback of previous versions. You can look at the historical trend. You can do a lot with deployments. It's a very powerful mechanism. And do sign up for this. In a day or two, we'll update cube.live with the registration page for this. Don't forget to sign up for that, and this is going to be very interesting. So we'll cover how to use deployments, how to perform rolling upgrades and do rollbacks, how to pause, resume deployments, and how to scale deployments. So those are the things that we are going to bring in the next webinar. So let me bring up a very quick poll to get your feedback. I really appreciate if you can take a minute and respond to this poll. I am personally committed to bringing the best content in simpler nuggets for you to understand and digest. And if you go to the playlist of my YouTube channel, and when you play back all the webinars back to back, that's almost like a course. You would basically end up learning everything from what is Kubernetes to some of the advanced concepts that we covered and we're going to cover. So your feedback is very important, and do let us know what you would want to see in the future webinars and what you feel about the current webinars. I see 80% of you voting for this. Appreciate if everyone takes a minute and clicks on those radio buttons to tell us what you really feel about this webinar. Fantastic. Okay, thank you so much. Most of you voted this as a useful webinar. Thank you so much again. And don't forget to sign up for the next webinar on scaling and managing deployments. That's coming up on April 18th at 9 a.m. PST. So thank you. Those are my coordinates. And all of you will receive a follow-up email with links to the slide share and the YouTube recording. So you can play back and go through the content again. And do share this with your friends and your colleagues who would want to learn Kubernetes, and ask them to register with cube.live. We are here to bring you best of the content from the Kubernetes community. Thanks again for joining us. Have a great day ahead, and I'll see you in the next webinar. Good day.